Hi, everyone. It's Judy Warner. Welcome back to the OnTrack Podcast and Happy New Year to you. We're delighted to be back with you again in 2021. And we have a wonderful guest for you today, which is Hans Klos from Syntecs. He is the CEO and founder and also a signal integrity expert for many years. I'm sure you're going to learn a lot about not only signal integrity, but about the amazing solutions Syntecs is queuing up for PCB design engineers like you. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack Podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hello, Hans. Happy New Year. Thanks so much for joining us today on the podcast.
Hi, Judy. Same Happy New Year to you as well.
So we learned about Syntecs or I did at Altium Live this year, and was delighted that you guys decided to sponsor and host a virtual booth. And man, hopefully this year will get us back into trade shows and meeting in person.
Definitely. I'm looking forward to that as well. Difficult year it was last year, but we'll do our best.
We are going to look forward to more in-person events this year. Well, Hans, I learned about an incredible tool that Syntecs has developed. And as the CEO and founder of Syntecs, tell us a little bit first about your background and then give us just a brief overview of what Syntecs does.
Okay, as Judy mentioned, my name is Hans Klos. I'm the founder, CEO of Sintecs. I founded Syntecs in 2000 by doing signal integrity consulting services. I have a background in telecommunications and since 1995, I'm working already with signal integrity. Initially with software like XDK and worked with many EDA software vendors for signal integrity. And still doing signal integrity. It's my hobby as well. And that's the basis of Syntecs as well. If you're looking at Syntecs now, we're not only doing signal integrity, but everything around electronic development, high-speed electronic development, all kinds of analysis to make the design working as optimum as possible.
So, Syntecs, you have an interesting product, which we're going to talk about more, which I think will be of a special interest to our audience. But let's talk about, signal integrity has grown up really in the years that you've been, involved in signal integrity. So let's get right to the issue. You've mentioned to me, and also our dear friend Rick Harley has talked about the impact of rise and fall times. Can you talk a little bit about that and the impact that's had over the last 20 years on signal integrity?
Oh, definitely. So when I started with signal integrity, back in 1995, you had rise and fall times of 5 nanoseconds, and you were able to route the signal around the edges completely around the board without having any signal integrity issues. And if you're looking what's happened during the last 20 years, the signal is becoming faster and faster. You see edges now, instead of 5 nanoseconds, edges of 25 or even lower picoseconds. And what I learned at least is that, in the beginning, a lot of people were skeptic about signal integrity because they were able to do some measurements in the lab. They trusted the feedback, the signals they see on their oscilloscope. But if you're now looking nowadays at your oscilloscope, you almost cannot measure your signals. By adding a probe to your signal, you already get this different view of your signal. So simulation is something that's almost every design needs to do simulation. And that's also, if you're looking what you see now, is that we need to train people as well in signal integrity because it's a lack of understanding. People understand some things about signal integrity, but if you're really talking about high-speed signals, people think about frequency of signals. So they are talking about, my signal is running at a frequency of 10 megahertz, so I'm not having any issues. Why should I care about signal integrity or controlled impedance? Well, it's not about frequency. can have a signal running at 10 megahertz, for example, a GTEC signal, and this signal has edges which are very fast, especially if you're looking at programmable devices. Often the GTEC signals you cannot program, and that means that you have unnecessary fast signals. That means that if you're looking at signal integrity, you need to focus on your rise and fall times, and that's at least what's a misunderstanding in the field, that it's not frequency, it's rise and fall times you need to focus on.
Yeah, and so those things are hidden from obvious sight, right? The rise and fall times. And so, like you said, if you depend on just your oscilloscope, you're going to what kind of problems are going to arise?
Well, the thing what I'm often seeing is if you're adding a probe to your signal, you're adding a few picofarad of loading to your signal. And then suddenly if you're putting your probe on your signal looks fine. But if you're removing the probe, your signal doesn't look fine, and you can't see it. For example, looking at, where is the signal switching? Is the signal switching on your pin or on your die? Well, the signal arrives at your die. So you actually need to simulate your signal, how it arrives at the die. And especially if you're looking at these very big packages you have, you can already have an interconnect length on your package of a few, centimeters. I saw sometimes 2 or 3 centimeters, so 40 millimeters. That's what I saw already. So if you're looking at the difference of the signal when it arrives at your pin and when it arrives at your die, it's already having a huge impact. So you need to simulate as well, or take into account the effect of your package interconnect. And that's something that it's making it almost impossible to do it with measurements. So you need to do simulation. And if you're looking at the current technique like high density interconnect, you directly want to route your signals inside the board. So by adding test points, you're making unnecessary steps. And that's also a difficulty if you're looking at very high speed interfaces like a multi-gigabit interface that's running at 25 gigahertz. Well, having a measurement point routed to the top of your board, it already creates a too big step, and the quality of your signal decreases. So you almost have no possibility to add test points. So you need to do simulation. And that's what I learned, in all these years, that the way people design boards, you need to completely change it.
You know, I think in the show notes below, I'll share with our listeners a really interesting podcast I did with Rick Hartley, where I think he was in the mid 90s somewhere, where he said all of a sudden everything stopped working and they couldn't figure out why, and just scratching their heads and all of that. And I'll share that podcast for our listeners below so they can hear, this point in Rick Hartley's history where he actually started chasing down the same issue that you're discussing. Now, so you had talked about some issues that are surrounding reference boards. Can you talk about that for a moment?
Well, if you're seeing it, at least it is becoming more and more complex to design a new board. If you would like to design a board with a DDR4 interface, for example, what you see that the semiconductor vendors often advise you to use signal integrity simulation instead of guidelines. But a lot of people have not the knowledge about signal integrity and running with the signal integrity software, using it for the design. So what do they often do? They're using a reference board. But the reference board is not developed for being used at an actual product. It's only being used at normal circumstance, ideal circumstance like temperature. And if you're looking at these boards, they are also not designed for a mass volume. And if you're reusing a reference board, then you're also reusing the issues in the reference board. So what I did often in the past as well, I show customers, I simulated the reference board before using it, because I did not want to blindly trust my semiconductor vendor if they are capable in designing a reference board correctly. And what you see as well, when I was talking to semiconductor vendors, they also told me, well, you know that we did not have a simulation model available when we were designing a reference board. So they were designing a reference board without doing simulation. And then you as a customer are reusing this reference board without doing simulation as well. So you blindly trust that the board is working. And when the board is not working, then what to do? Because you don't have an idea about how is the interface developed, you just copy the routing. Well, maybe you have a different manufacturer as well for your printed circuit board. So your impedances changes because, well, maybe they modified something in the stacker. So all that kind of things is never trust a reference board. That's always what I do. And if you would like to copy it, simulate it up front. And then you know at least the quality of your reference board. But still, it's better to simulate your own design instead of just guessing and hoping, fingers crossed, it's working. Because that's what you do then. And then the board comes back from manufacturing and it's not working. And you're spending hours, weeks in the lab to find out what is the issue. And what I recently saw as well with a customer, they came to me, well, the reference board is working, but my board not. How is it possible? Then I said, okay, which version of the reference board did you use? Is the simulation database or the design container you're using, is that the same version as the final one? And that's always often also the case that manufacturers don't update the reference boards with the latest version. So you're also copying the mistakes of the reference board inside your design. So I never trust a reference board myself. And I'm using simulation software always to develop my board from scratch. That's the experience what I have.
So you've mentioned a few reasons why it's critical to simulate, even if you don't have screaming fast speeds. So can you explain some other reasons why it might be important to simulate versus just design and measure?
Oh, definitely. So, I compare always, if you're looking at a printed circuit board, and especially the printed circuit boards we have now, I compare it to developing an ASIC. So if you're an ASIC designer, you spend a lot of time developing the ASIC, but it's often only 1/3 of the time you're spending in developing the ASIC, but it's 2/3 of your time is making sure, doing all kinds of simulations to make sure that the ASIC is working right first time. Because it's very expensive to develop a mask for an chip. So you need to be 100% guaranteed that it's going to work. Well, why don't you do the same when developing a printed circuit board? Because how much delay do you have? How much time do you lose when your first, second, or third prototype is not working? And what I'm also seeing often is that companies plan prototypes. They would like to have the first prototype in 2 months, then 1 month after, 1 month after. They're planning 6 prototypes. And if you're planning 6 prototypes, you will get 6 prototypes. But the issue is often the design engineer, the layout engineer, often makes the layout as quick as possible ready to make a first prototype. And yet you're already using wrong information when you're each time modifying the printed circuit board. So it's better upfront, design right first time. And that's my methodology. I never design a prototype. I always design a product and directly making it right first time. And that's the difference what I'm seeing. You save a lot of time, because how much time do you save if your product is having 2 prototypes less? Or how much time or money do I save when I just need to produce 1 batch and it's directly working? So that's always what I advise. It's not looking at the price, the investment, what it will cost to do simulation, but how much money do I save when my prototype is working first time? That's what I often advise people. Simulate.
So different people that have joined me here on the podcast have been saying that in years past that the problems were in other places in the system. In other words, the noise, it was somewhere else in the system. But now people are reporting that many more, if not all of the issues are on the board level. Do you think that's contributed, this sort of shift towards board level, that maybe that's not widely understood? And why do you think that's happened?
Well, the most important thing, what I'm seeing, at least when I'm talking with people, that they have some basic understanding about transmission line techniques, but they have never thought about it, how it works on a board level. So what I'm seeing that they think, well, my emission of my board is the most critical because it needs to pass my EMC levels to make sure that the board is CE, FCC certified. But what you often see is if you're designing your board for signal integrity, you're designing it to make it as quiet as possible. So if you're looking at undershoot, overshoot on your signal, it contributes for your emission of your product. So if you lower your emission, your undershoot, overshoot, it lowers your emission as well. If you're looking at crosstalk also has impact about radiation emission of your board. So if you design it, making sure your undershoot, your overshoot, if you're looking at your crosstalk as low as possible, what you also see is that the your radiation of your board, it will pass your certification, EMC certification. So that's one of the things that I'm seeing, that it contributes a lot. And people not thinking, wait a minute, emission and signal integrity is something different. No, everything is similar in one way. If you're looking at power integrity as well, looking at your power and ground bounds, these kind of things, it's also something that is contributing to the emission of your board. So a lot of things you can do, but that's also what I'm trying to do, is teach people, let people know about what is signal integrity. It's a few rules you can already use by understanding your boards and looking at your board, like selecting a component. A lot of people are not aware of that, but if you're looking to design a new product, why not looking for the right component to use? So if you have the choice of 3 vendors, look which one is maybe the slowest device, because you have only an interface running at a lower speed. So why always selecting then the most faster device? So that's kind of things you can focus on in selecting components upfront. Looking at the placement, so already in placement, you can do some things when you route a critical signal till a final board. So a lot of knowledge people needs to gain, but by the end, it is possible. It's possible to learn, and that's what I would like to do. People understanding signal integrity, learn more about it, but also make it easier for people to understand and to use it on your board.
Yeah, I think that's the key, right? Is sometimes I think it feels like black magic, but if there's, like you said, some principles that you can apply, something you and I had talked about earlier was the role of IoT and how that's driving an increased need to simulate. Well, IoT devices don't seem particularly challenging. Why is that? Why is that a driving force for the need to simulate?
Well, actually, if you're looking at the latest chipsets which are on the market, they are all developed by the latest standards, latest technology. They need to be low power. So if you're looking at an IoT device, it needs to be wearable, it needs to be portable, battery powered. So what you often see, they are using the latest kind of technique. So low power, running at 1 volt. But it means as well, latest technology, they are also using the latest lithographic, technology. So that means that the latest technology of chipsets is also making the rise and fall times faster. So it comes back to rise and fall times the same time, because if you have only 1 volt instead of 3.3 volt for switching, you see as well, your levels are closer, your edges are faster. And that means as well, you get a lot of issues with signal integrity as well for these IoT devices, because they are still very fast. So it comes back in everything. And that's one of the things that you see, at least with IoT devices, that the other issues is often they are using chipsets where maybe the simulation models is not available. So you see sometimes chipsets which are very low cost, but the documentation is also not that great. So if you don't have good documentation, not having simulation models, what you often see then is you're building a board and hopefully it will work, but you have no guarantee about that. So it's becoming more and more important. And if you're looking at the next step is emissions, radiation of your devices as well, it's also an issue, because they're all probably wireless connected. They having a Wi-Fi interface or some other kind of wireless interface. They need to be certified as well for some regulations, and they don't pass as well. So what to do? So it comes back to a lot of things, this signal integrity.
Well, Syntecs has come up with something that I'm excited about personally, because I've sort of been knee deep in this segment of the industry for many years, and it's a really great solution. So why don't you talk to us a little bit about, how you've come up with this solution, how you're making, helping this, sort of bridge this gap that exists for design engineers in the market today.
Yeah, so the reason why I started to develop a product that makes it easier to do signal integrity simulation was that, we did a lot of PCB layout designs we did in the Altium tool flow. And what we often saw is that, setting up a database costs a lot of time. And especially if you do several iterations, so you would like to do an SI analysis on the placement, critical routing, other routing, each time you had to set up the design. And there was a lot of manual things to copy files. And I thought that must be much easier to do. So what I was looking at, well, all the data is available in the Altium tool flow. Let's reuse all the information. So what I did, I created a connector called the HyperLynx Connector. And what it did, it gathers all the data that's already available in the Altium database in this connector, and makes it much easier to export data to the simulation, the signal integrity simulation, HyperLynx, what we use. And within HyperLynx, we can then easily simulate a complete board without each time need to set up everything from scratch. Because you sometimes run maybe 10 different analyses on a board, and each time you need to set up a database, and that's time consuming. I thought, well, we must make it much more easier to set it up, to reuse the data you already set up and learn from it. And actually at the end, I would like to select a net within Altium and then say simulate, and that just my waveform is popping up. That's at least the thing what I would like to develop now. And I developed the HyperLynx connector. It's a free connector. It's not something you need to buy now. It's just for free to make people easier to work with HyperLynx. So that was the motivation behind. For now, it is only doing signal integrity, but I would like to go as well to other levels, going to for power integrity, so that you can look at your decoupling of your planes as well, how it is done. So we are importing and developing a lot of new functionality in this connector to make it easy for Altium users to work with signal integrity. So that's what I would like to do and what we're busy with the HyperLynx connector.
Well, HyperLynx is well known as a great simulation tool. It's been around for a long time. And I think that a lot of people that are maybe, a one-person design bureau or a few people think, wow, well, HyperLynx is a great tool, but way too rich for my blood. It's an expensive tool because it's a great tool. So, great that the connector is free, but is there a way that design engineers can access HyperLynx in an affordable way?
Oh, definitely. So what we did as well with the team behind the HyperLynx, what we developed a special bundle for the Altium designer users with only the functionality where every user is requesting. So every user would like to do a signal integrity simulation. So they would like to do a single net simulation. They would like to maybe multiple net simulation or a complete board or a multi-board analysis. But that's the main thing that they would like to do. They maybe have not multi-gigabit. If you look into all the kinds of simulation software, they offer you a package which is much more expensive because they have a 3D solver, multi-gigabit. Well, if you're talking about IoT, most of the designs are not multi-gigabit. They're having just interfaces. Maybe DDR3, DDR4 is the maximum speed grade, 1 gigahertz, 2 gigahertz. And you can still do it with the standard solver. That means why spending a lot for a signal integrity software? Well, you don't need all the functionality. And what we developed now is we have a bundle, a special HyperLynx bundle for the Altium users with only these functionality for only 1,500 euros annually. So every year, 1,500 euros instead of more than 10,000 of euros or dollars for a license that you need to pay minimum. And that's at least what we decided now with the HyperLynx team, is to develop a bundle special with only the functionality that makes it as well affordable for people. So for only 1,500 euro, it's a promotion price we have. It's the Altium Live promotion what we have. Normally this license costs less than 3,000 euros per year, but now for 1,500 euro. And 1,500 euro, comparing that you can save maybe one prototype run. If you say, look at how much money it saves you, it's much more you save than this 1,500 euro. And the other nice thing is about HyperLynx, it's very easy to use. You don't need an expensive training course to work with it. There is a lot of information available how to run a signal integrity simulation with HyperLynx. And we also try to train people as well for free with methodology trainings for signal integrity. So I think it is worthwhile to investigate this connector in combination with the HyperLynx software. And as mentioned, you save already a lot.
Well, I'm very excited and encouraged to learn about this because I think that's been a big barrier to entry for some simulation tools. And as you know, we're starting to put more and more simulation tools, with 3D field solvers inside of our own tool. But I think this is an easy way to get in quickly and do, like you said, the fundamentals when you don't have a multi-gigabit system, which is sort of overkill for a lot of these devices. Now, one of the things that I've been really encouraged in learning about, something you and your team are doing, is the training that you just mentioned. And when we're sort of in this post-COVID world, it's not always easy to either get trainers to come in or that. And so you're talking about offering more and more online training. Can you tell us about your plans there?
Oh, definitely. So one of the things that will be available beginning of next year is for all the people who downloaded Connector and is willing to evaluate the HyperLynx suite. We also provide them a free 2-hour introduction to signal integrity. So it's not a tool training, but it's just basic training where you need to think about, because a lot of things, it's just thinking about rules. Maybe all these rules you already know, but in this training, we will provide it for free. You'll get an introduction, all kinds of signal integrity effects. So it helps you already a lot. And that's the first training that we will provide for free. It will be available in January, February, I hope at the end of January. And this is just an online video. You can watch it and learn about signal integrity. The next steps, what we also would like to do is also an introduction in the Hyperlinx simulation. So if you still have issues that how to set up a design, we can help you with it as well, with a free training. So we are trying to help the users as well to learn how to use the software, but also learning about signal integrity and kind of things where you need to think about. So that's kind of things we are going to set up as well, and will be available soon as well on our website.
Well, again, Hans, this has been great to learn about this. And, it's really great to have someone like you that has so many years in signal integrity and being able to just hand off some basic principles, have that, it's affordable. The training's free. It's online. This is music to our ears, and I'm sure to the ears of the Altium community. So thank you so much for joining me today and sharing with us what you talked about at Altium Live, and for extending this offer to our listening community.
You're welcome, Judy. Thank you as well for making this possible and having this conversation.
Yes, it's always my pleasure to serve up great people like you, Hans, and the solutions that are offered by companies like Syntecs. And I hope we can talk you into maybe a co-webinar with Altium in the new year sometime. I'm sure we'll put something together.
Perfect.
To our listeners, thanks so much for joining us today. I hope you've enjoyed learning about simulation and these principles, as well as getting to know Hans and the solutions that Syntecs is putting together for you. We hope that you will come back next week when we'll have another great guest here on the OnTrack Podcast. Meanwhile, please take a moment to review the podcast. It really helps other people to find this resource. We appreciate you. We're looking forward to a new year here with the OnTrack Podcast. We'll see you next time. Until then, remember to always stay on track.